So welcome to today's final lecture dealing with nomenclature of compounds. We're going to review molecular and ionic a little bit and then finish off our discussion of the acids. And so we said, generally speaking, we divide compounds into two groups, molecular compounds and ionic compounds. The molecular compounds exist as their molecules, and they have molecular formulas. Molecular formula is a list of exactly the number and type of atoms you need to make one molecule. What's holding the molecules together are shared electrons. We talk about covalent bonding. And generally speaking, molecular compounds tend to be soft and low melting materials. And in fact, many molecular compounds are liquids or even gases at room temperature. So in naming a compound, you first have to decide which category it falls into. For example, sulfur 2Cl6 is all nonmetals, so you'd expect it to be a molecule and you'd name it using the molecular nomenclature, disulfur hexachloride. SO3 is again going to be a molecule, and again you use the nomenclature sulfur trioxide. Technically you should have the mono in front of the sulfur, but as we said, when you have exactly one of the first one, people often leave out the first prefix. K3N, on the other hand, you'd expect to be an ionic compound, since it's a metal and a nonmetal. And the cation is potassium, and the anion is nitride, and so the compound is potassium nitride. Again, you don't use the prefixes here because this is an ionic compound. For ionic compounds, you simply list the ions and let your audience assemble the right numbers of them. So what formula would go with the compound name calcium nitrate? Well, this is clearly going to be an ionic compound since it includes a complex ion. The calcium ion, being an alkaline earth, would have a +2 charge on it. Nitrate is NO3 with a -1 charge. And so we have to indicate we have 2 nitrates for each of the calcium ions in the compound. So what compound would you expect to get out of a cobalt-3 cation and cyanide? Well, it's going to require there to be 3 cyanides for each of the cobalts because it has to be neutral. And of course you have to put the brackets around the cyanide to indicate you have 3 cyanides rather than just carbons and nitrogens. And cobalt cyanide. Well, cobalt cyanide would be insufficient because cobalt, of course, is a transition metal and has more than one oxidation state. So you have to give the charge on the cobalt. So it's a cobalt +3 cyanide. So how would you name that compound? Hydrogen, nitrogen, and 3 oxygens. Well, you might think that it should be a molecular compound. It is, after all nonmetals. Hydrogen, nitrogen, and oxygen. But on the other hand, the NO3 is clearly a complex ion. So is this thing an ionic or a molecular compound? And the answer, of course, is that it's actually neither. It fits in our special category of being an acid. The special thing about acids is the presence of hydrogen cations. And hydrogen cations are special. Most of the volume of an atom is occupied by the electron clouds. And for most cations, although they have lost some of their electrons, they still have a large number of electrons forming their electron cloud. And so while cations tend to be smaller than the atoms they came from, they still are roughly the same size as the other atoms. A hydrogen cation is different. When you take away an electron from a hydrogen atom, there is nothing left but the nucleus. And the nucleus is 1/10,000th the diameter of the atom. And so when you take away all the electrons, what you have is simply this small positive nucleus. A hydrogen cation is 1/1000th the size of any other cation. And because it's so incredibly small, it doesn't behave the same way any other cation behaves. And as a consequence, compounds which include hydrogen cations are not going to behave the way any other compounds are, because the hydrogen cation is going to make them different. So since the acids are behaving differently than other things, the question is how do you tell whether something is in fact going to be an acid? And there's a fairly simple way to tell. You simply have to look at the formula. A compound that is going to be an acid is going to have hydrogens in the cation part of the formula. That is, at the beginning of the formula. Those where you have hydrogens later in the formula, those are not going to be acid protons. So those three compounds, even though they have hydrogens, do not have hydrogen cations available, and so they are not acting as acids. When you see hydrogens later in the formula, they are not going to be acid hydrogens. The other requirement for being an acid is that, in fact, the hydrogens have to be the only cations present in the formula. Those three compounds, all of which have hydrogens present as cations, are not acids because they have some other cation present as well as the hydrogens. They are just simply ionic compounds. To have it be an acid, the hydrogens have to be in the first part of the formula, that is the cation part of the formula, and they have to be the only cations you have present in that compound. Acids have essentially two formulas that we run into commonly. The first one is simply binary acids, that is, hydrogen and some other element. The other kind of acids we most commonly run into are hydrogen, some other element, and oxygen. And so we talk about oxyacids. Since the acids do not fit into either of our two categories, molecular or ionic, neatly, how do we go about naming acids? Well, depending on which form the acid is we have a set of rules for naming acids. The simple binary acids, if nothing else is available, you can simply name them as if they were ionic compounds. Consider these two simple binary compounds. The simplest way to name them, and what you should do if they are in pure form, is to name them simply as if they were ionic. Therefore, the first one would simply be hydrogen chloride. And the second one would simply be hydrogen sulfide. And like I said, if you have them in pure form, they're both gases at room temperature, you should simply name them that way. If, on the other hand, you have them dissolved in water, then the correct way to name them is you add the prefix hydro. Hydro means water, so you're talking about something in water with the prefix hydro. You then mention the anion's name, and you change its ending to ic and add the word acid. So HCl in water would become hydrochloric acid. H2S, hydrogen sulfide dissolved in water, would become hydrosulfuric acid. And so in pure form you should name them like they're ionic compounds. In water, you add the prefix hydro and change the ending to ic acid. The other kinds of acids that we run into are the oxyacids. By now, you should recognize that the oxyacids are hydrogen cations in some kind of a complex ion. And again, you can name such compounds as if they were simply ionic compounds with hydrogen as the cation. So to name these two compounds as if they were ionic compounds, you simply have to go instead and name the hydrogen and follow it with the name of the complex ion. So those two compounds could be simply named, respectively, hydrogen chlorate and hydrogen sulfate. And that wouldn't be wrong. But most people wouldn't expect you to name those as if they were ionic compounds. They'd expect you to name them as if they were acids. And we have a special set of rules for naming the oxyacids. To name an oxyacid as an acid, you start out by naming the complex ion you have. And then you change the ending of the complex ion, which is either ITE or ATE. ITE changes to OS acid. ATE changes to IC acid. So first of our two oxyacids would simply be chloric acid. Since the chlorate is the anion, the ATE becomes IC, and you add the word acid. And the second one, which is based off of sulfate, the ATE again becomes IC acid, and so the second one would be sulfuric acid. This is something you have to pay attention to. People often use hydro thinking that it's a prefix meaning hydrogen. It doesn't mean hydrogen. It means water. And more specifically in the nomenclature, it means you have a binary acid in water. You can't simply add the prefix hydro to everything. HCl in water is hydrochloric acid. HClO3 is just chloric acid. Hydrogen sulfide dissolved in water is hydrosulfuric acid. H2SO4 is just sulfuric acid. You have to be careful about hydro. It has a very specific meaning in the nomenclature, and you can't just add it in anytime you see an acid. Some of the most common acids that we run into are oxyacids. For example, HNO2, the anion is NO2 minus, that's nitrite, so HNO2 becomes nitrous acid. HNO3, the anion is nitrate, NO3 minus, so that is nitric acid. H2SO3, the anion is sulfite, SO3 minus 2, so that becomes sulfurous acid. And H2SO4, the anion is sulfate, so that is sulfuric acid. And that concludes today's discussion of naming compounds, molecular, ionic, and acids. Have a good day.